Hello and welcome! In this lecture we're going to build upon our move action and set up our code in such a way that makes it easy to add many more actions. We're also going to create a fun spin action just to test out the code architecture. Alright, so here's our game so far. We have a move action and all kinds of validation, and visually we can see where we can move. And of course we have multiple units and each of them can take a move action. Now let's make another action, but also make sure to write our code in such a way that it is super easy to add even more actions. For testing, let's build a slightly silly but very visual action. We want an action where the character pretty much just spins in place. That's it. So let's begin in our scripts folder by creating a new C# script. For this one, let's call it the spin action. And again, if you remember how we're handling our actions, we're attaching them to the unit. So let's select the unit prefab. We have our move action, and now let's also add our spin action. So just attach the script. Okay. Now in this script, we're going to need a public function to take this action. So let's do that. Let's do a simple public void and just call it spin. And now here the goal is to make the unit spin 360 degrees. So let's do that simple logic. We're going to do that over time. So we need a private void update, and we need to know when to spin. So let's start a bool start spinning. When we spin, we set this to true. And on update, if we are spinning, so if start spinning is true. If so, then let's just add a spin by adding something onto the transform.Euler angle. So plus equals a new vector 3. And for spin, we only want to spin on the y-axis, so something on the y, nothing on the x and z. And then just define a certain spin add amount. So the amount we're going to add per frame, so 360 degrees. All right, this is our basic spin logic. Now it's actually never going to stop spinning, but still, let's test like this. Now in order to set up our test, first up, we need a reference to the spin action in order to be able to call the spin function. So for that, let's go into the unit script. Okay, so here we are. We have a reference to the move action. So let's add another one, but this one for the spin action. And same thing, we get it over here on awake. So get component of type spin action. All right. Then we need to expose it. So let's do just like we do over here on the move action. Let's expose the spin action. Okay, so just like this, we should be able to call the spin function. Now I swear we're going to call this. Let's go into the unit action system over here on this script. And right now in our logic, so far we still don't have any way of selecting the active action. We're only doing a move action. We're going to add some proper action selection in a bit. But for now, just for testing, let's do left mouse button to select and move and right mouse button to spin. So let's do an input, get mouse button down. Testing for the right mouse button, so button index 1. If so, let's go into the selected unit, get the spin action, and call spin. Okay, so with this, let's test and see if by right-clicking on the right mouse button, if in doing so, the character does start spinning. Let's see. Okay, so here we are, and if I right-click, yep, there you go, the character indeed does start spinning. Alright, so far so good. However, we actually have one crucial issue with how we set up our logic. So we're doing a spin, okay, that's nice. However, if now I attempt to do a move action, yep, there's the issue. So once the movement starts, it stops rotating, then when the movement stops, it continues rotating. Let's go into our move action script, and over here for the rotation, here's where we're handling it. So we're only rotating while moving, but let's say we're always rotating towards the target position. So let's put this logic outside of the if, so to make sure that it always runs. So we need the move direction, so let's compilate this outside of here. Okay, so this way we are always going to be rotating, whether the unit is moving or not. And to see the problem that this is going to cause, let's go into the spin action, and over here, let's add a simple debug.log just to make sure that we run this function. So debug.log and call spin. Okay, so let's see what this does. Okay, so here we are, and if I move, okay, yep, it still moved correctly. However, now if I right click, and nope, there's our issue. So the spin action did indeed run, so we can see in the console, we can verify that that function was indeed called. However, as you can see, the unit is not rotating. So that's the issue. Right now we have two actions both fighting with one another. Both of them are trying to rotate the same object at the same time. Now, thankfully, we have a super easy way to solve this problem. Our game is turn-based, so we really don't want multiple actions happening at once. So our simple solution is simply going to be to enforce that. Make sure that only one action runs at a time. For that, let's go into our move action script. And here we basically just need to know if this action is either active or not. So if it is active, then we want to run the basic movement code. But if it is not active, then we do not want to run this code. So let's go up here and define a simple bool. So private bool, call it isActive. Then basically on update, we're only going to run this logic if it is active. So we can do that very simply by checking if we are not active. If not, then we can just return right here. So we don't run any of this code if it is not active. Then all we need to do is play around with this field. So let's go into our move function. When we call this, set isActive into true. And all that's left is just the final destination on the update function. So here we are testing the distance to the target position. If it is further than the stopping distance, then we do keep moving. If it is not, then that means we have reached the target position. So over here, let's set isActive back into false. Okay, so that's it. Just some simple logic, and now it should be working. So let's test. So here we are, and if I move, it works. And if I right click, and yep, the spin does work. So now only the spin logic is active. All right, awesome. Now, of course, we also need to add the same logic to the spin action. Otherwise, if I click, yep, both actions are colliding. So let's sort that. And in doing so, we're actually also going to solve the other problem that we have here. The spin is meant to be just one revolution, so just 360 degrees and stops. Whereas right now it is currently spinning forever. So handling that logic is going to be your simple challenge. Your goal is to add some logic to the spin action to make it spin for only 360 degrees and then stop. Alright, so go ahead, pause the video and give that a go. Okay, welcome back. So let's add this simple action. Let's go into our spin action class. And up here we currently have the start spinning. We can actually rename this in order to make sure that we keep things with a nice standard. So here we're using a bool isActive. So over here, let's use the same one. So call it isActive. And by the way, the hotkey that I used was F2, which is the same thing as right-clicking and rename symbol. Okay, so isActive, changed all of them. Then we're only going to run the spin logic if it is active. And again, let's use the same pattern that we use on the move action. So we test if it is not active, we return instead of doing this. So instead of testing for isActive, then we do this. Basically, the only difference is if we go like this, then we end up with quite a lot of indentation on our logic. Whereas if we do this, then we can simply reduce the indentation here so everything looks a bit cleaner. Okay, so if this action, the spin action, if it is not active, then we don't do anything. And if it is active, then we're going to spin. Now, the next thing is really just keeping track of how much we have already spun. So let's go up here, make a private, make it a float, and call it the total spin amount. When we start spinning, let's set this one into 0. Then when we add, we spin, and let's increase this by the spin add amount. And finally, just do a simple check. So if the spin add amount, the total spin add amount, if this one, it is bigger than 360 degrees. If so, then we have a full revolution. So let's end our action. So isActive back into false. Okay, so that's it. Some very simple logic. We can also get rid of the log. We no longer need this, and let's test. Okay, so here we are. Let's right click to spin, and yep, there you go. It did one revolution and stopped. Now I can click to move, and yep, this one move, stops. Now rotate. Yep, it does work. Move and spin and so on. And I can even select the other action. Now spin, now move and spin again and so on. All right, awesome. So here we have two actions and we no longer have a collision between both actions. However, we still have a problem if we try taking both actions at the same time. So if I move and spin, there you go, it gets very weird. But don't worry about that for now, we're going to solve that issue later. Right now, let's just clean up our code. Looking at both of our actions, so both the spin action and the move action, both of these have quite a bit of common code. Both of them have a boolean for isActive. Also, all actions will probably need a reference to the unit. And later on, we're going to implement even more common logic to all the actions. So this makes it the perfect case to create a common base class to all of our actions. So let's do that. Back in the editor, let's right click, create a new C# script. For this one, let's call it base action. And again, we have quite a few scripts here, so we can actually group them. So let's make a new folder for the actions. And let's put the base action, the move action, and the spin action. All right, now let's open up the base action script. And over here, this is going to be the base action like the name implies. So let's leave it as monobehavior since all actions will be used as components. And then here, let's pretty much write just all of the common code to all the actions. So like we saw, two things we want from the move action is the unit and the isActive. So let's copy this and put it in the base action. Okay. Then for getting the unit, let's make a simple awake. And on awake, just set the unit equals get component of type unit. Okay, that's good. However, one thing here, this is going to be our base action, meaning our actions will extend this class. And in those actions, we're going to need access to this unit and this isActive field. If we set them as private, then we cannot access those from those child classes. So instead, we can make them protected. Protected is very similar to private in that no external class can touch this field. However, classes that extend this class can indeed access them. So that's exactly the level of access we want. If you want to learn more about protected, you can check out the Microsoft Docs linked in the resources for this lecture. Okay, so these are the basic fields for the base action. Let's go into our move action script. Let's get rid of the unit and the isAction definition. And instead of extending monobehavior, let's instead extend our base action. And here we actually have a slight issue. So on the base action, over here we already have an awake to get the unit reference. However, on the move action, we also need this awake in order to access the target position. So let's refactor this. On the base action, instead of making this a private void awake, let's make it protected, so it's accessible to any child classes. And then let's also make it virtual, which means that those child classes, like the move action, can override this one. So let's go into the move action, and over here, instead of private, let's make it protected, and now we're going to override the previous awake. However, we still want to run the base awake, so the base action is getting the unit, we still want to run this. So we basically want to run this, and then after that, we want the awake specific for the move action. So how we run this is very simple. We just use the keyword base and then call the function. So base.awake. So that means that the move action will still run the awake from the base action, and then afterwards it will run the transform position. Okay, so just with this change, we have no more errors here. Everything is correct. Now let's do the same thing on the spin action. So over here, instead of extending monobehavior, let's extend our base action. And let's get rid of this one isActive. And everything else is still the same. Okay, so let's test and make sure that everything still works. So here we are, and if I right click, yep, there you go, still have the spin action. Now I left click, and yep, there's the move action. Alright, so both actions still work great. Let's just do one more thing over here in our base action. For this class, we can add the C# keyword abstract. What this does is it does not let us create an instance of this specific class. And that's exactly what we want. We want to create instances of all of our actions which extend this class, but we don't ever want to instantiate the base class directly. By adding the abstract keyword, it pretty much means that the compiler will enforce that rule, so if we accidentally try creating a base action object, it won't work. Alright, so here we have successfully added multiple action types. We have multiple actions that we can take, each of them start and stop, and everything works perfectly. And of course, we set up our code in such a way that makes it super easy to add many more actions. The only issue we have is that we currently can take two actions at the same time, which kind of breaks things, so let's sort that out in the next lecture.